Welcome back to Math 130, Applied Algebra and Trigonometry. Today we're going to talk about Section 13.3, Properties of Logarithms. Logarithms were developed in the early 1600s as tools for astronomers and navigators. The slide rule was developed soon thereafter. It was used, and tables of logarithms were also used until the 1970s, when scientific calculators came into widespread use. But that's enough history. Let's do some math. Please do not get hung up on the x and the y and the u and the v. Pay attention to where they are positioned in each equation. This is the exponential form. Let's convert it to logarithmic form. Notice that the only letter that is the same in all four of these equations is b, the base. Now let's explore something else with these. Let's look at what x times y would be. X is equal to b to the u, so let's substitute that. And y is equal to b to the v, so let's substitute b to the v for y. So now we have b to the u times b to the v. According to the laws of exponents, that is equal to b raised to the quantity u plus v. And if we recall that because x and y are multiplied together, they are one term, we actually have a very basic form of an exponential equation there. We have an argument, a base, and an exponent. That means we can convert this exponential equation to logarithmic form. Thus we have the exponent, u plus v, and that is equal to the log base b of the argument xy. So now we have u plus v over here. We also have u and v over to the right-hand side. And in fact, we want to know what those are equal to. And we can take the log base b of x and substitute it any place we see a u. Likewise, we can take the log base b of y and substitute it any place we see a v. Therefore, the left-hand side of this equation becomes the log base b of x plus the log base b of y, and that is equal to the log base b of xy. And that is the first property of logarithms that you need to know. It is generally written in the reverse order, as you'll see, because now it's time to begin our list of the properties of logarithms. Okay, the logarithm of a product, or the product rule for logarithms, is as follows. The log base b of a product, xy, is equal to the log base b of x plus the log base b of y. Let's see an example of this in action. If you were given the log base 3 of 20 and you wanted to do some manipulation of that, this could be rewritten as, let me use the color coding that I've been using. There's the base, and 20 is actually the product of 4 and 5. Okay, so it could be rewritten as the log base 3 of 4 plus the log base 3 of 5. Now that didn't seem very spectacular, but watch this. The log base 2 of 20 would be the log base 2 of 4 times 5, and that would equal the log base 2 of 4, which looks interesting, plus the log base 2 of 5, which is rather less interesting. We can evaluate one of those logs. The log base 2 of 4 What exponent of 2 will give you 4? The answer is 2. So we now have 2 plus the log base 2 of 5. So we have evaluated that as fully as we can without a calculator. I'd rather not reinvent the wheel this semester, so I'm going to add someone else's video to my playlist, and this gentleman will show you how to do logarithms and square roots and other roots on the TI-89 calculator. You won't need to know how to take them on a calculator today because we're going to be using these properties to evaluate them as fully as we can without a calculator. But you'll need that in the future, so it will be there for you. So that was our first property of a logarithm, of logarithms. So let's talk about another property of logarithms. Let's talk about the logarithm of a quotient. So we just did multiplication. Now we're going to do division. So we're going to be looking at the log base b of x divided by y. Okay, the log base b of x times y led to an addition, to a sum. The log base b of x divided by y is going to lead to a difference. Log base b of x minus log base b of y. Why does that work? Well, it works because of this. Previously, we defined x to be equal to b to the u and y to be equal to b raised to the v. And we talked about how we converted that to logarithmic form. So converted to logarithmic form, u equals the log base b of x and v equals the log base b of y. So we're going to use that again in just a moment. So if we're looking at x divided by y, that's going to be equal to, x is equal to b to the u, and y is equal to b to the v. So since the base is the same, that whole thing is equal to the base b raised to the u minus v, according to our laws of exponents. Okay, so what does that mean? Well, we can take this equation. Let's get rid of what's in the middle there. Okay. And let's scoot this over. Okay, so now we have an exponential equation in a very simple form because this is one term. So we have an argument, we have a base, and we have an exponent. Let's get rid of my squiggles here, and let's convert it to logarithmic form. So we're going to do that by taking the exponent, okay, and it's going to come down here as u minus v, just as it is up there. That's the exponent. The exponent is what the whole log is equal to. So that is equal to the log, the base is b, and the argument is x over y. Okay? However, it still doesn't look like the property over there, the logarithm of a quotient. We have to do another couple of substitutions here. So we know that u is equal to the log base b of x, and we know that v is equal to the log base b of y. So this is where we go back and do that substitution. Now we have the log base b of x. Okay, that came from there. Minus the log base b of y, which came from here, and that is equal to the log base b of x over y, which is what we already had on that side. And then if we just switch the order, we have it the way it is written over here. The property or the rule for the logarithm of a quotient. Let's see that in action. Let's look at the log base 5 of 0.3. Okay, so you may be saying that is not a quotient. It's just 0.3. Where's the quotient in that? But how do you read 0.3 really if you use place value? You read it as the log base 5 of 3/10. 0.3 is also read 3/10, or it's written as a fraction in that way. And now we have a quotient. So the log base 5 of 3/10 is equal to the log base 5 of 3 minus the log base 5 of 10. Not terribly impressive, right? But what if this were a slightly different problem? What if we had started with the log base 5, not a decimal, let's start with 3/25, okay, with an actual fraction that's easy to see. Log base 5 of 3 minus log base 5 of 25. That's a bit more interesting, because although we cannot do anything with this log base 5 of 3, we can evaluate the log base 5 of 25. What is the exponent that you can use with the base of 5 to get 25? The answer is 2, because 5 squared is 25. Before we go any further, I want to raise a huge caution. We have the logarithm of a product here. We have a logarithm of a quotient here. We are going from, in the logarithm of a product, we are going from multiplication, okay? When you're thinking about this, you're going from multiplication to addition, okay? Or from multiplication to a sum. In the logarithm of a quotient, you are going from a quotient or division, okay, to subtraction or a difference. All right? So think of that when you're thinking of these. You cannot do this. You cannot take a sum out of a logarithm and separate it into another sum in this fashion. You do not go from addition to addition. That is a no-no. Also, you do not go from a subtraction to a subtraction. Do not do that. That is not true. It's only from a product to a sum, a quotient to a difference, or multiplication to addition, or division to subtraction. Of course, you can go the other way. You can go from a subtraction of separate logs to one single log with a quotient. You can go from an addition of two separate logs to one log with a product. Okay? Be very careful. I will end this portion of the lesson on that caution, and the next part of the lesson will be contained in Part B of Properties of Logs 13.3. I'll talk to you soon.